now we come to the interesting part. Yeah, let's talk about operational technology, OT. So a lot of people talking about IT, and René Bispering is working in both worlds, so in IT and OT. But today we want to learn about everything which can go wrong in OT. And I think it's a lot of interesting stories you will present here.
Yep.
And yeah.
Yeah. So first of all, thank you a lot for having me. This was a little bit of a last moment decision. A acquaintance of mine and a colleague of mine, Jean-Paul, wasn't able to do this talk. So indirectly, they basically asked who wants to do this talk and or who wants to represent, basically. So that's basically why I'm here. So for today, I'm going to talk about the O in OT, so basically the operation, but you can also call it the O in OT, so especially for what can go wrong. And some people might even say that as in some ways you could also even see it as the uh-oh in OT. With this presentation, I would like to highlight two major perspectives. First of all, from the asset owner and or site owner itself, the operator perspective, and also from a different part, also from the more security tester and or hacker-oriented perspective, because that's most likely why a lot of people basically are here. So in this talk, I'm going to first of all talk a little bit about a couple of examples of hacks over the years, also some visuals on how they worked on a high over level and what worked and also what didn't. And from there, talk a little bit about the standards surrounding it and tying it basically all together into how can you actually get involved, because there is still a great need of people who know what they're doing and basically help protecting OT, because it's becoming more and more important. So I was briefly announced, but sometimes I announce myself in the presentation anyway. I'm René Bispering. During the day, I'm a security tester, an ethical hacker for the most part, and at night I'm still often a security tester and an ethical hacker. Other than that, I like to call myself a professional tinkerer, or as the people from the Netherlands would call it, een professionele prutser. So in a lot of ways, I like to tinker, see how stuff works, how we can basically build it up correctly, but how we can break it, but also how can we actually fix it. So, basically to start off this presentation, I often like to do an audience check. Who of you have configured and or interacted with a PLC before? So, basically a lot of people. Who of you knows how Modbus and or a Modbus attack works? A little bit less, but very interesting. And who of you have actively tested security of an OT production system and or environment? Oh, also a couple of you. So there are, of course, a lot of things that people like to say about OT. So operational technology is often the systems like production plants, power plants, refineries, and they are basically designed for 24/7 uptime. Just like the last speaker mentioned, if a production loss occurs, that can mean €1,000 a second even, or maybe even more. So it's always a balance between security of what do you actually want to protect versus how do we actually keep this plant running. And it also focuses on a lot of different things than IT. So in OT, you're having a really large emphasis on safety, reliability, and continuity, because that's basically the most important part. Some people like to call OT old and unwieldy. I call it purpose-built in a lot of cases, and but still often old and unwieldy. So, throughout the years, various hacks got in the news. One of the major examples is the Colonial Pipelines ransomware attack. Let me see if that is the correct slide. Yeah, it should be. From there, there are, of course, a lot of examples that we can broach. A couple of them I'm now pointing out on the screen. So there was the Triton attack. You have the Black Energy hack. You have the Ultimax Florida water plant. You have the steel mills, and you have a lot of unknown cases where the actual asset owners and or site owners don't want to disclose the details of those hacks. So for today, I've prepared a couple of cases to talk you through it. Some of them are, of course, in a demo environment, but basically to show you on a high over level what actually happened and or how does such an attack actually then work. So the first case I want to broach is basically the Triton attack. It consisted of a couple of steps. First of all, how did the hacker actually get in? Well, it was, or it basically did turn out that the initial access point was actually spear phishing. So a specific email was sent to a specific engineer of a site that was specifically targeted based on information he or she should only know themselves. And it was really targeted to get malware onto their system. Afterwards, the attacker was able to move laterally over the network and then also bypass certain segmented networks in order to get actually access to the OT environment, from which the controller was reverse engineered, new firmware was uploaded, and custom malware was being written to basically to disrupt the safety system. In the end, the goal was basically to do an emergency shutdown, cause as much disruption as possible, and even cause physical damage. Yeah. So, I mainly asked about Modbus a little bit, because in that specific case, one of the major attacks was based on the Modbus TCP protocol. The previous speaker already did talk a little bit about a specific plant and a chain where boxes ran on and fell off. But in order to do that, you, in the foreground and or background, need to interact with Modbus. What was found out was that a specific controller was basically simulated in order to get actually access and allow certain things to occur. So in this demo, or basically this Python script, I'll basically walk you briefly into how can you then actually interact with Modbus to see first of all how it works, and then second of all what can you then also do to protect against this. So if you see the script, it starts off with creating a socket. A socket is basically a small connection to a different endpoint. From there, you basically enter the IP address and the port, which might be very familiar towards what you might be accustomed to. If you, for example, want to browse to a certain website, you often enter the IP or the domain name, and in some ways, sometimes also the port in order to reach the specific site that you're looking at. For Modbus, that's not really that different, although in this case we're doing it on a script basis. The second part gets a little bit more interesting, because you see that there is a payload actually defined. If you see this payload, what are basically the first reactions from you? What does it look like? Is it anything recognizable already, or are you saying it's just gibberish? Sorry? Anyone else? Yeah, so basically the payload is basically how this script would then interact with Modbus. It consists of two different parts. The first part basically with the first 2 bytes indicating what is actually the transaction ID. Afterwards you have the protocol ID. For Modbus that's basically always 0. So the first 2 bytes indicates basically the transaction ID. In this case, that's just set to 1. On the second part, the protocol ID is set to 0. So the second and the third and fourth byte are basically set to 0, because that's basically always the case for Modbus. And in the end, you have the length, which indicates the length of the rest of the bytes. In some ways it might sound a little bit difficult, but the rest of the remaining bytes is basically the indication how long is the rest of the packet and on what data are you actually going to send. In the second part, it will focus on the actual data being sent. First of all, you have the function code. In this case, it's set to 5 to write to a single coil. There's the second part focusing on the coil address, which in this case is set to 1. And basically the last 2 bytes are indicating, well, actually I'm trying to write a 1 to that specific coil. So in this case, that means turn a specific part on. If the last 2 bytes were set to 0000, it would basically mean that you would basically turn that device off. And on a high-over level, that is basically how you can interact with Modbus. And in a lot of ways, this might sound difficult, but there are also libraries to help you with this and start learning basically about how does this then actually work. A good example of that is, for example, the PyModbus module. A different case that was also in the news a while ago were automatic tank gauges. So basically those tank gauges were exposed to the internet on port 10,001, and they were basically used to see the fuel level in gas stations. So as you might imagine, them being exposed to the internet might not have been the best idea directly. In a demo setup, we rebuilt basically how such a controller would work, and basically how you could also interact with it. Do note that this is not our work, but it is existing work that some people really worked hard upon. We can, of course, also provide the details for how they broach it, because basically all of those tools and scripts are also available on GitHub. So basically what this then actually does is then it basically connects to a certain service on port 10,001, and if you use certain specific codes for that ATG, you can actually then interact with it over the internet directly. A lot of those vulnerabilities are now being patched and are already patched. So I wouldn't go directly looking into gas stations, but there might still be any vulnerable even available on the internet. And in this case, or in this example, I don't know how readable it is, but it uses a default function code I20100. So if you've never worked with it, you can, for the most part, forget it, but that's basically a way to interact with those ATGs. I just mentioned that there are also a lot of easier ways to interact with it, and the same guy that did a lot of research into the ATGs even created an Nmap script for it to basically check whether you could actually then exploit this, and even exploit it very easily by basically making some assumptions and only having to enter the IP address and the port. And from there, it basically received the same output and or the same result. So what I wanted to show, of course, with this is that in some ways, simple tools and scripts still work within OT. And some might require, of course, a little bit of tinkering and or a little bit of scrutiny. But in a lot of ways, it can be easy to learn about OT security by basically doing. I'm saying doing it in a tested environment, often a home lab, etc., in order to get experience with how does this then actually work. The previous speaker then talked also about a couple of defenses, which are in a lot of ways maybe difficult for certain OT environments, like the active monitoring. One of the most difficult parts to prevent basically the Modbus attack that I talked about in case 1 is that then you're actually needing to know what specific traffic is actually going over my OT network, and is that then actually valid traffic. A relevant point was also made that some asset owners don't really know what is then actually the process versus what is an attacker actually doing on that specific network, which makes it, of course, very difficult to determine, well, is it actually valid traffic or is an attacker actually on my network? Yeah. And last but not least, there was a case of the Ukrainian power grid that some of you might have heard of, in which the attacker got access to a first IT network and was basically downloading a payload from the internet. So as you might assume, especially if you're in an IT network that often has internet access, but often through lateral movement, either through moving over the network and or moving just in general in a different way to the OT environment, might even be with a $5 wrench, then there are several ways of reaching that OT network. Of course, this is a very simplified script that basically shows, first of all, what an attacker would be doing. So first of all, they would download totally not a backdoor into the network. From there, basically create a scheduled task to maintain persistence, and then start executing the payload. The thing that in this script and or this execution is that it can, of course, be very difficult to determine what is it actually doing. Although over the years, of course, a lot of changes have been made to protect against those attacks. So maybe to summarize, so what does this script then actually do? First of all, it downloads a malware file from a malicious server. It registers a scheduled task and then starts executing. Further than that, especially in those power grids, there were also some other actions that are not part of the script. For example, a lot of log data was deleted, and a lot of other parts were obscured and or removed in order to stay undetected. Of course, if you think about 2025 versus 2015, you can, of course, argue that there are a couple of asterisks to this. Modern defenses in cases like these would most likely kick in, especially if you start to download totally not a backdoor to the network. Especially because those detection capabilities get more and more advanced. That also means that attackers are now more using different methods as opposed to 2015. So basically, it always stays a cat and mouse game. Other than that, of course, running payloads like not a backdoor directly, of course, has a very high risk of being detected in 2025, especially if modern antivirus systems are used. However, in a lot of OT networks, you still see that not every OT system and or engineering workstation can or wants to run antivirus. Also, one of the last asterisks that I wanted to talk about is that scheduled task scheduled tasks are basically one of the major ways of getting persistence, with the downside is that it is one of the major ways to get persistence, so it's also one of the most figured out ones. Just like bits, for example. Bits is the background intelligence transfer system on Windows, which is often then also used for maintaining persistence. So, why did I talk about this and show you these cases and these examples? Well, first of all, in a lot of ways, attackers maybe attack the IT network first in order to get to the OT network. So it takes multiple skills in order to successfully get access to such targets. However, you see more and more that a lot of OT providers now also provide remote access solutions for monitoring purposes, secure updating purposes, and more, so that more PLCs and or OT systems are now then also directly connected to the internet. As a security person, you might argue, well, I don't want my OT network connected to the internet, but at least the reality shows that more and more devices are then actually going to be connected to the internet. In the previous talk, there was also an example of Stuxnet. Well, one of the initial entryways was, of course, an engineering workstation that got its privileges escalated through a printer driver. So, in order to get further access into the network. So, there are, of course, still a lot of sneaky and intelligence ways attackers can get into the network and stay there and or pivot towards the targets that they actually want. Yeah. So, the previous speaker also briefly talked about it. So, if you want to get involved, there are, of course, a lot of common OT protocols and or networks that you can learn about / learn from. So, some protocols might be very interesting. Some of them might be interesting in the way they are configured, and some protocols might be even interesting in the way that some consider them insecure. So there are, of course, various ways to learn about this, and if you're interested in it, I can provide a couple of resources after this talk, basically to learn more about it. Yeah. So what does this then all tie together to? Well, one of the biggest challenges, at least that we see so far, is that it is in some ways very difficult to convince executives of security risks and the associated costs and or the impact of that. Because executives in a lot of ways are top strategists and not OT security experts. And in some ways, even not OT experts. So what that does mean is that in a lot of ways there is a large emphasis on do actually then listen to your specialists, because they often have the knowledge in order to help you secure those networks. And what we still see is that many of those decisions are then still being made without actually then understanding those risks. So, the bottom line. Ignorance in some ways is the biggest risk within OT security. So why do I then actually mean or mention that? There is still a lot of unknown about OT security. How do I actually protect my plant, and what actions am I actually going to do in order to basically keep my plant secure and keep it from being hacked into ransomware. So there are then also some regulations that are then trying to drive this change. So some of you might have heard about the NIS2. Some of you might have heard about the Cyber Resilience Act. Earlier this morning there was also a talk on why 2025 about the Cyber Resilience Act. Unfortunately, I wasn't able to attend that one, but in a lot of ways, those two standards are then mandating newer and or extended OT security practices from two different perspectives. The NIST2 is more oriented on a higher level, so for the most part focusing more upon risk management, incidents reporting, business continuity, and even a little bit of supplier management. As a site owner or as a plant owner, it then also involves him or her in order to determine what actual stakeholders do I actually have, what third parties are then actually connected to me, am I getting any service provider integrating something into my environment and or to my system, and even what are the risks associated to those. I know that I'm just going over this very briefly, and there is a lot more to it, but the extent is that the NIST2 for the most part then focuses upon the higher level. The CRA, on the other hand, then focuses a little bit more on the products, the software, and all the other mechanisms within such an environment. I heard some questions about now encrypting for example, certain traffic to and from devices. Well, in the CRA, they are basically making a lot of that mandatory. Whether that's feasible for all types of systems is then still a second question. However, it then tries to, from the product and or software perspective, give a couple of security guarantees in order to determine basically the basic safety and security of those products. So, why am I then still mentioning this? What we see is that the gap between CXOs and OT is often still large. And with the emphasis on the standards that I just mentioned, is that the top executives aren't in the NIST2 then being considered liable, and also for the CRA considered liable for the risk management and the actual actions they can and do perform. And they can, in theory, I haven't seen it yet in practice directly, they can also be prosecuted if something really goes wrong. The main question is then, how can executives be responsible for risks they do not understand? And that's basically what ties together this presentation, is that in the end, we need to get a bigger proving ground and or collaboration between the OT experts, the OT process monitors, the operators, and the actual board in order to get a secure environment. So, and what can you then as a hacker do in order to learn and move into OT security? Because there is, of course, a large need of both security professionals that actually know about the technical details, but also one that focuses upon risk management and informing. So what are then actually the risks? There are, of course, a couple of things that we need to take care of. First of all, in order to make OT a little bit safer, we need to know people who know OT, and both in the technical side but also in the functional side. So what can you then, from the hacker perspective, then actually do? So, in a lot of ways, know the asset owner's assets. And that can be the asset owner being yourself, by knowing about your operational environment and your home lab, in which you can try out new stuff, but also learn how networking then works in order to see how did an attacker actually move, for example, from the IT network to the OT network. Because in a lot of ways, a lot of asset owners are talking about, well, we're actually segmenting our network, or our OT network is not on the internet, or it's air-gapped. But in practice, it turns out that there are still, in some ways, a lot of backdoors and or options to still reach that OT network. Other than that, there are also a list of community efforts like the Mitra attack framework, which some IT professionals might be aware of already, but it's also available for OT. So what this does is basically it shows the tools, the tactics and the procedures from adversarials to see basically how did they actually get access, what are common ways that adversaries actually get access to such a network in order to prepare for as a defender, for example, how do normal attackers actually get in. The step 1.5 and learning the basics is basically see or look into the Mitra attack framework, because it really gives you a frame of reference into what operations is an adversary then actually trying to do. First off, it starts off on a high over level. So first of all, for example, what are ways of gaining initial access to the network? That might be spear phishing for some adversaries, that might be the $5 wrench for some other adversaries, or it might even be getting in through a web application to get access to the IT network in order to move then laterally to the OT network. So this framework and frame of mind gives you indications of, first of all, what would an adversary or a hacker do? And second of all, by knowing these steps, how can I then actually defend against this? Because in some ways, I like to say the best defense can be prepared if you know how the offense works. And last but not least, I would really recommend building a test environment. Hopefully not in production. From there you can try out a lot of things, see how actually things work in the background, see how you can interact with it, see how you can break it, but also see how if there are any ways to fix this. Because together with attacking, there's also a large need of people knowing how to defend against these attacks. So in the example that I showed just before about the automatic tank gauges, I used a tool called GasPot, which is basically a gas line honeypot built basically together to test out certain attacks and certain protocols in order to learn more about it. There are also other environments like Conpot or other specialized environments that you can learn more about how these attackers then actually work. Yeah. So in the end, specialized tooling is often available, but not always needed, at least to get started. In the end, it might be more useful getting to specialized tooling and equipment, but in a lot of ways, there are also a lot of free or very cheap ways to get started with OT security. Yeah. So, as a conclusion, OT is critical and must be secured. That is one of the statements that you might have heard a lot. But in general, what then comes down to is how are we then actually going to secure this? And we can do that both from the attacker perspective and the attacker mindset, but also on the defender mindset with knowledge about such an attacker. So what this then also shows is that in a lot of ways, adversaries and or people talking about OT security basically combine a lot of expertises together. Because if you saw one of the examples, it was interacting with a Windows machine, and from there it was moving over the network and then actually interacting with an OT protocol like Modbus TCP. So it combines then multiple factors together and basically chains some vulnerabilities together in order to reach such an endpoint. Last but not least, there are of course a couple of standards supporting OT, but they don't always fully apply or cannot always fully apply. And that just means that we have to basically apply the right controls suitable for those environments. And if they can be applied, of course, apply those changes. Yeah. And last but not least, I want to thank you for joining me. And I'm happy to talk further. This was a little bit of a summarized presentation, and a lot of technical details are left out, especially to keep it in a time window. But if you're happy to talk about it, I would be more than happy to also talk about it after this presentation. Yeah.
Yes, thank you.
Questions?
And additionally to talking with you afterwards, we have now really a good time for questions. And also we have a signal angel here. So if you are listening on the stream, so just send your questions over there, and then we can ask them here. But we have already the first question here in the chat.
Oh, nice. Yes, sir.
Maybe.
Yeah, working.
Yeah.
Okay.
Yeah.
You suggested one of your solutions to protecting OT would be to implement some controls. What would the controls be for you to implement in OT?
I have two different answers on this. The first one is, of course, the technical controls, mainly consisting on network segmentation and the high over coverage of monitoring. So first of all, identifying what is then in your network, first of all. So first, passively monitoring what is actually defined as normal behavior, for example. And from there, you can then somewhat accurately make a process, well, this is the normal operation. And from there, you can then actually do anomaly detection into your network, maybe even first passively, but then maybe later on also a little bit actively. And the second part, of course, then consists of more the risk management part, because basically everything in security comes back to risks. So what is then actually in your environment, for example, the assets, and second of all, what are the risks associated to those, but also, of course, keeping in mind what are the risks of any downtime, for example, when having to apply certain patching. Does that answer your question already?
Okay. Sort of was the answer. And we have already the next question here in the tent. But first, have a look into the internet. No?
Okay.
No question from the internet. Then we have the next question here. I come to you.
My question is, how do you deal with the long-term that OT is often in use? So if we have IT equipment, it's a few years in production, but if we are in the OT environment, we have systems that run for 10, 15, 20, or even 50 years.
Yeah, exactly.
And how do we design a security that will stand for 50 years?
Yeah, very good question. I don't have the full answer to this, because otherwise I would be very rich, most likely. And second of all, it is not an easy problem to solve. However, there are certain defenses, especially that you can apply, so that it doesn't matter little and little, or matters less and less how secure your actual products or components are, if the rest of the operational network is then actually considered secure. So I talked a little bit about network segmentation. That is, of course, one of the solutions, by really knowing what is available on your network and or the outcomes of it. You can somewhat prevent a lot of those attacks, and of course providing certain access controls, encryptions, etc., encryption mechanisms which are not always applied yet. However, the CRA, for example, does enforce encryption for, of course, the components that are relevant in that case. However, I still foresee a large problem of actually trying to apply encryption on a lot of OT devices. So I don't have a full answer for you at that point, but there are, of course, controls that you can implement in order to secure your network as much as possible, and that still allows the operation to function correctly. because that is, in the end, is maybe one of the most important parts. You can have as much security as you want, but the operations should still be running, because that is basically earning the money. Did that answer your question? Thank you. Any other questions?
Yeah. Over here.
Oh, yeah.
You talk about the right priorities. Availability is key, and then it's safety, and then security at the third level.
Yeah.
Maybe even lower. What you refer to is the dependency on isolating, and maybe air gapping. All those technologies do work. I also see where certain factories have a certain standard way of being built. You can actually define a reference architecture for wind turbines, for solar parks, how they are connected to grids and other technologies, and learn the sensor data and train that in a machine learning model. So you can actually detect potentially when an adversary is trying to mess with your Modbus signals, if they ever entered at that level of your OT domain. Any thoughts, any views from your side, any experience?
So for the most part, it's not try to avoid AI, but for the most part, I avoid AI. But definitely, they can be a useful tool if, of course, the operators and the humans are still in control. Because at this point, the operation and the staying of the operation is maybe one of the most important parts, but I definitely see the advantages of AI being used in order to, for example, do that anomaly detection. You see that's already happening more and more in intrusion prevention systems, intrusion detection systems, and more, even on solutions specifically targeted towards OT, in order to basically do some heuristics on what is actually then happening, and do I foresee an attack going on, or just someone messing something up.
Yeah, one of the things was like Modbus injection, as you highlighted.
Exactly.
But if you're a man in the middle, if you're between your wind turbine, for example, or your inverter, and the operator, you can trick the operator with false data, of course. Now, if you use a reliable external source like weather and conditions that need to match up with what the wind turbine is actually supposed to be doing, the speed, etc., you cannot really simulate or replay the same sensor data as an attacker. So it would then be trained to detect the anomaly.
Yeah, definitely.
So, any more questions? So first again, a look into the internet. Oh, the internet has something?
Ooh.
No.
Okay.
So
the internet let me down.
Yeah, so OT people don't like the internet.
Fair enough. They have segmented the network.
Yeah. So maybe they're already typing the questions, but they don't end here. So, more questions here, inside the tent or outside, if you're standing outside. No. Then, thank you again for your talk.
Thank you.